Hello everyone, I'm Farzana Afruznila. This is my first task as a data science and business analytics intern at the Sparks Foundation internship program, which is prediction using supervised machine learning. The objective of this task is to predict the percentage of a student based on the number of study hours. The first step is to import libraries. I have imported all the necessary libraries here. The next step is to import a set from online. As the dataset contains comma separated values, I used pandas.readcsv method here. We can see the dataset contains two variables, hours and scores. Hours is the independent variables, scores is the dependent one. I used dataset.shape to know the rows and columns, and that is 25 and 2 respectively. I also performed missing value analysis in the initial stage of data preprocessing, and there is no missing value in this dataset. Now to represent data graphically, I used matplotlib library to create a scatter plot, and we can see a positive linear relationship is visualized here. In order to prepare data, the dataset is divided into attributes and labels, whereas labels is the predicted values to be predicted. After that, we will split the data using scikit-learn building training test split, that is used for splitting data into two subsets, training data and testing data. The next step is to fit our model into the training dataset. Here the linear regression class of the linear model library is imported from scikit-learn. After importing the class, we will create an object of the class named reg that will fit our function method with our training data, so that the model can learn the correlation between the prediction and targeted values. As we trained our algorithm, the next step is to prediction. Here ypred is a numpy array that contains all the predicted values in the x-test series. The next part is to visualize training dataset and test dataset. Here we can see the training dataset. The green spotted ones are the actual value and blue line is the regression line that is predicted. In the comparison analysis of actual and predicted values, we can see the values are pretty close to each other. Here comes the model evaluation, which is the procedure to justify how well-defined algorithms actually performed. Here mean absolute error 4.69 means my predicted value is more or less than the test set of 4.69 differences. Finally comes toward the problem statement, and we got our predicted score at 92.14. That's all. Thank you.